Hello everyone. Today I'm going to talk about the PLDT, a multi-layer and cross-domain transport network automation. Let me just get started with a quick introduction of the PLDT group. The PLDT is the Philippines' largest and only integrated telco company with a key business in mobile, enterprise, fixed line, and IoT. PLDT runs its mobile services with the brand Smart. Smart Communication has the 73 million subscribers with the mobile services 5G with the services offering the 5G, 4G, 3G, and 2G, and with the added 3.8 million subscribers with the Smart Grow and Sun Wireless Broadband. With the enterprise, they offer services intended for enterprise customers, the corporate consumers. That includes corporate data, ICT solution, data networking, cybersecurity. The PLDT runs its broadband services with the PLDT Home. They provide the broadband services, triple play, and IPTV. With the IoT, they have multiple offerings in place with a smart end-to-end SIM, cloud push-to-talk, digital forms, and digital operations. With this, now I'm going to talk about this PLDT network transformation journey. PLDT network transformation, a multi-year digital transformation that started with a partnership with Cisco. And I'm going to start with some of the key codes on this major investment. The PLDT have the ability now to, with this major investment, to take the entire flow to the next level with the technologies as digital technologies as 5G, SDN, artificial intelligence, and Internet of Things. With this network being ready, the PLDT and the Smart has the 5G rollouts made easy because the base network and the scale what the 5G needs is ready. Not just for the mobile services, even with the enterprise, with the fully automated network, the PLDT's enterprise customers can expect more tailored fit digital services that meet their business specific needs. Not just for today, even for looking in the future. With this pandemic environment, the operational agility has been improved with the network and the new technologies, what is built with. With almost 95% and 98% of the employees working from home, with this new technologies they are able to provide the added capacity, activate their services, and optimize and manage user experience. Now, let's just get started why in this transformation, what is the role of automation and why we need the automation. There are some key asks from automation, the agility. The services need agility in adopting frequent changes. What it means is when you run a service in a network starting for a particular vendor, why just don't move the service to if I need a movement of a service from one vendor to the another vendor, what if I need some of the quick changes in my service to adopt the new requirements coming up from the enterprise? Visibility has been a key challenge for our day-to-day operations. It really becomes impossible or even challenging for the users or the customer to get a hold of or without a grasp of our services where my services are running. With the automation, every line of the configuration should be traceable to the original intent. The efficiency, even enablement of the network should be easy and cost effective. And why and what? Let's just look at that. What we are looking from the ask of the efficiency. For example, if I have a multi-vendor network, now a network engineer who's looking for a service enablement does not really need to deal with the complexities on how you configure a service on a vendor A and how you configure a service on a vendor B. It should be simple and have an abstracted view of a service, what it contained my service is looking for. Simplified management, the management of a network services should remain simple with the growing complexities. As my network grows and becomes more agile, the management should remain simple, and the automation has to play a key role in that. network programmability, no CLI, no human errors. Now my services in the network has a ask that they should be running with the best practices. To run in the best practices of with the services, network programmability is a must to deliver with consistency and accuracy. Now with these asks and the expectations on board, let's just get started on how we have started this journey and what do we do with the network and how we have done the automation with the NSO in the transport network. We have built a cross-domain and multi-layer service orchestration, which is spanning across the two vendors or the two domains, one being running with the Cisco and another with the third party. In the Cisco network, we have a multiple network segments, and same goes with the third party network. Each segment, for example, the one segment is the IP core and optical core. The optical core running with the DWDM and OTN layers, which provides a connectivity to the IP devices, the IP core devices. And NSO makes sure that we have a provisioning across the layers done. Starting from the layer 0, making the DWDM circuits up to the, or connecting it to the OTNs, and then providing access or running the IP services, the overlay services that are over it. We have all the flavors of the MPLS overlay services like L3 VPN, L2 VPN running with the eVPN. And the same flavor of services is mapped to the metro network, which is the access network. NSO also have the service parity running across the Cisco and the third-party vendor. Now, with a quick look on the networks, what we are surveying with the NSO, let's just move to the controller architecture. How we have placed the controller architecture, which is the NSO typed with the different components. On the top, we have a BPA, the business workflow, business process automation. BPA plays a UI, the user interface for all the services offered by NSO. And it also tied each service with a workflow. It means a user who's trying to manage a service or even trying to create a service has a workflow tied to it. It means there are steps a user has to go through doing a pre-checks and post-checks, and users can make sure that whatever the service is provisioning, what the impact on the network of what actually they are pushing into the devices. The abstracted view of the services with the business catalog is also being provided. For example, now I have a baseline L3 VPN services. Now that same flavor of the services get used by the enterprise as well as the mobile. What the BPA does, it can provide you the abstracted business catalog. It means you have a separate catalogs to manage your enterprise services, where the separate team on the same flavor can manage it with the different catalogs. And the view is abstracted based on the catalogs being provided. The network service orchestrator, the main service orchestrator who's spanning across the multi-layer and across the domains, provides the agnostic view of the services across the vendors. It means how I run a service in Cisco and how I run a service in third-party network. It has an abstracted view. The users just look at a service and the structure of the service remains same for how you run in Cisco network and third-party network. A complete lifecycle management of the services is done by the SO, maintaining the capabilities of the resource orchestrator instances. It also makes sure that all key resources being managed by the service orchestrator. On the leftmost, we have a domain controller, which is the resource orchestrator managing the Cisco IP devices, which is spanned on the IP core devices or even the metro network. It also exposes a netconf interface to do the integration with the service orchestrator. We have a Cisco EPNM managing the Cisco devices, the optical Cisco devices, and also expose a RESTconf interface for the SO integration. The same structure is being mapped with the third-party controllers. We have a third-party IP controller and we have a third-party transport controller. The third-party IP controller has also managing the same in the same manner the IP devices spanning across the IP core as well as the macro segments, and also exposes a standard REST-conf interface to do the integration with the SO. The last, a transport controller managing the optical devices. With this hierarchy built on the controller, let's just move to the use cases. And I'm going to start the discussion on what we have achieved with the IP services on the overlay and the underlay. I'm going to start with the overlay services. With the overlay services on the mobile, we have the end-to-end transport service orchestration done for 2G, 3G, 4G, and even the 5G, upcoming 5G services. It means if we have either we have a southbound of a mobile site, the radio site, and the transport needs to be enabled. There is an endpoint service get provisioned, and even the packet core where you are aggregating all the traffic for the radio sites also gets enabled by the NSO. The service orchestration to fulfill the need of the 5G network slicing. The services which are being ready, they make sure that we have the capability to fulfill the need what the 5G network slicing is required when you enable a service in the transport network. It also provides you a topology-oriented VPN profiles. And specifically on the VPN profiles, they are the profiles spanning across all the sites. That's a common profile which gets mapped on the services or your sites which are running it. On a topology-oriented view, either a particular service, whether it's need a hub and spoke connectivity, it means my sites need not really talk to each and every one together. They only have one common place on the hub side, and all the sites, spoke sites, need to get communication with the hub. Or even with the ask of the hybrid VPN, where I need to run a separate segment of running as a full mesh, and my end-to-end connectivity remains a hub and spoke. We have a different kind of flavors running and making sure that all the needs of the mobile site services, whether it goes to the 2G and 3G or 4G, 5Gs, are being met. And when we are spanning these mobile services across the multiple domains, the visibility of the mobile services becomes a key ask. Now, what we have done is you have a same VPN profile which is spanning across all the domains. It means when you have a radio site on a Cisco domain, or you have a radio site on the third-party domain, you have a consolidated view under the same VPN profile. Moving to the enterprise services, even with the present offerings, the PLDT has the IP VPNs or the different flavors along with the IP VPNs being provided in form of a lease line and or the L2E lease line services. We have all the flavors of the enterprise services getting provisioned, whether it's related to the L2 VPN or a point-to-point or a point-to-multipoint services with the L2. A bandwidth calendaring use case where a enterprise customer looks for a bandwidth upgrade or a downgrade based on a schedule window. For example, a customer sees a spike of a traffic, or they want to have the more traffic flowing in on a certain period of a time, on the day or a month. What a user facilitates here is you can go and do a bandwidth calendaring schedule, which can be it can be a one single schedule, or it can be a recurring schedule where you can see upgrade and downgrade being performed automatically. A bandwidth on demand, as and when you need a upgrade and downgrade, a service facilitates you to do the changes. Entire lifecycle management of the enterprise services being done. And also we have each service running, the enterprise service running has a service metadata, which provides a correlation of a service order management system with this. So it means if you are referring a service which is in your order management system and you want to see how's that service being provisioned on the NSO, with the service metadata, any enterprise customer or the user can make a correlation on that service. On the third use case, the the broadband services. The orchestration of the internet broadband services is being done by the NSO in the transport network. Again, it facilitates you to enable all the endpoints. A endpoint which is doing an aggregation for the OLTs or the endpoint mapping it to the BNG endpoint. A voice broadband services, the IPTV services. With these overlay services also come with the need of traffic steering. It means if we have a service looking for a specific constraint to run in the network, a user does not really want to leave the service to running with the default path. With the underlay services, with the NSO facilitates that we have a traffic engineering paths can be created or a tunnels can be created with a dynamic, static, and on-demand next stop, and attach it to the intended service. And its service can be spanning across the mobile, enterprise, or fixed. And it also specifies the constraint. Now, I want my traffic engineering path to be running with a low latency path to the path which gives me assurance to a defined bandwidth. The all options we have with the traffic engineering and make sure that the traffic steering of a particular service in the network is done as intended. Now, with the IP services, let's just have a quick look on the optical circuits and services. With the optical circuits, which is again being facilitated on both the domains, whether it's a third or the Cisco or the third-party network, the use case enables both the layers, the OCH or the DWDM layers, the colored wavelength with the path being defined. And then we have the OTN circuits with the path protection. And NSO, the service creation has a single view of a service configs across the layer 2, layer 1, and layer 0. Multiple variants of the client signal mapping is also being achieved. For example, if I am offering a client port on a router, whether it can be a need of a 10 gig or 100 gig, gets mapped, and the same service has adopts the changes or even the different variants which you are looking for with respect to the bandwidth. On the optical circuits and services, having a flexibility of a mapping of the circuit to the different client ports. Now, like we are mapping the client port to the infra router, it means we are spanning a connectivity to the IP core routers, or we are offering a corporate lease line. The service orchestration makes sure that you meet your intended client ports. Now you can either map it to the routers or provide an IP connectivity or offers to the corporate lease line. And now I move to what we have achieved so far and what has been outcomes from the service orchestration done from the NSO. With this new network being ready, the migration is one of the key asks, and we have been able to deliver the migration efficiency while moving a service from an old network to a new network. With the present state, we already have 11,000 services migrated in a short span of time, and many thousands are more forecasted. The service agility, the EG lifecycle management, which comes by default from the NSO. It means you're doing any update to a service, a turnaround time for any config change is very quick. We have been able to manage the consistency and accuracy. While each service gets provisioned from NSO, there are a minimal to null manual configurations being done in the network, which leads to no human errors. And the last, the visibility. We have been able to see a good visibility across the services for the network services being provisioned. Now, with the network services, how that a service getting provisioned on a domain A and to domain B has it gets a visibility across a single service or a VPN. NSO also provides a good resource management for the key parameters, whether it's being a globally unique or a locally unique, and make sure that when a service is done with the allocation of a resource is being done with the unique values. Now, with this outcome, I open up for the questions.